네. Good morning and welcome back, and thank you for joining us for the second day of Seoul Forum 2026. My name is Yeon-ah from Seoul Economic TV, and I'll be serving as your MC for today's program. We had the opening ceremony and keynote address, and we had an incredible day yesterday. And we also have a really good turnout this morning, and I'm really happy to see you this morning. This year's Seoul Forum brings together world-renowned scholars and experts in AI, robotics, and digital technology from around the world, continuing in-depth discussions under the theme Beyond Intelligence Toward a New Engine of Industry, New Core, and New Industry. Let me briefly walk you through today's agenda. We will begin with an opening address, followed by special lectures from distinguished speakers representing both academia and industry, offering forward-looking perspectives and profound insights into the future of industries being reshaped by AI. And following the special lectures, three main sessions will take place. Each session will have in-depth presentations and discussions across key fields. This morning, right after the special lectures, we'll move into session 1, Redesigning Industry, the Physical Revolution led by Robotics, exploring the groundbreaking ways humanoid robots are transforming the industrial landscape. After session 1, we will have lunch in this room for about 90 minutes. And this afternoon, we begin our program at 1 p.m. And we'll begin with session 2, Redesigning Life, rewriting the blueprint of life with AI, examining the latest cases of AI expanding the frontiers of life sciences. And from 3:30 p.m., in session number 3, Redesigning Reality, the birth of a virtual world more precise than reality, will take place, where we will explore how digital twins are revolutionizing industry infrastructure across the board, bringing our full session lineup to a close. We'll be able to listen to many experts from the industry and academia. Now let us officially begin Day 2 program of Seoul Forum 2026. First, I would like to invite Mr. Son Dong-young, CEO of Seoul Economic Daily, for opening remarks. Please join me in welcoming Mr. Son with a big round of applause. Good morning. I'm Son Dong-young, CEO of Seoul Economic Daily. In the month of May, as the vitality of spring flows into the energy of summer, it is deeply meaningful to be able to discuss the future of Korea's industry together. I'd like to once again welcome you back to Seoul Forum 2026. So today is the Day 2 of Seoul Forum 2026. Yesterday we had many participants from home and abroad, and we shared deep insights into how AI is reshaping the order of industries and society. And today's main sessions will take a more concrete look at the currents of the AI era from the perspective of the industrial front lines and explore the direction Korea must pursue going forward. First, I'd like to thank all the participants. Today, scholars, business leaders, and experts from Korea and around the world have given their precious time to participate in this forum. I'm truly grateful to all the speakers and panelists who will diagnose how AI is evolving into a new engine of industrial growth and share the experiences and insights they have gained from their experience. Korea is now confronting both the speed and depth of the industrial transformation triggered by AI. Yesterday, we examined the broad currents of the AI era, and today we aim to look more concretely at how that change is being realized on the ground. AI has now moved beyond being a technology that demonstrates possibilities. It is becoming a real-world driving force that is transforming production methods, research and development, and operation systems. In particular, physical AI and robotics are setting new standards for productivity and safety on the floors of manufacturing, logistics, and shipbuilding. Bio and healthcare AI is broadening our understanding of disease and expanding therapeutic possibilities, transforming the approach to life science. Digital twins and industrial AI are establishing themselves as tools for predicting and optimizing complex industrial environments, emerging as key variables in corporate competitiveness and national strategy. And today's forum will address these concerns intensively through three main sessions. We'll examine how physical AI and robotics are transforming industries, what new possibilities bio and healthcare AI is opening for human life and health, and how digital twins and industrial AI are innovating corporate productivity and operations. Through the discussions of world-renowned scholars and industry experts, we hope to gain a clear picture of the practical strategies and possibilities of the AI era. What matters now is not an declaration but an execution. We must move beyond simply calling AI the future of industry and translate it into tangible results across production floors, research and development, supply chains, and service as a whole. To achieve this, data utilization capabilities, the capacity for on-site application, and the connection between talent and research ecosystems must all be strengthened together. Competitiveness in the AI era depends on not how much technology one possesses, but on how quickly that technology can be converted into industrial value. Through this forum, Seoul Economic Daily seeks to examine closely the future of industries being transformed by AI and to find solutions for Korea to secure leadership in the global competition. We'll discuss how to turn AI into real industrial competitiveness, what preparations business and government need to make, and how technological advancement and human values can be brought into harmony. Once again, I'd like to thank all the distinguished guests and audience who have joined us for the main sessions of SEOUL Forum 2026. Thank you very much. I hope that this will serve as a new starting point for a greater cooperation. Thank you very much.
개회사전에 주신 서울경제신문 서울경.
So that was the welcoming remarks of Mr. Dong Young-soon, the CEO of Seoul Economic Daily. We will have a festival of knowledge, and now he pointed out that what is the direction of this Seoul Forum. Now we would like to move on to the special lecture, and for this first special lecture, we invited a special person who is leading the studies at the intersection of AI and medical sector. Professor Soo-in Lee of the University of Washington, who has earned international recognition as a pioneer in the field of explainable AI, will deliver a talk. Professor Lee transformed the interpretation of machine learning model by developing SHAP framework, and for the first time in 34 years, she became the first woman winner of Samsung Hwang Prize in Engineer. And she is currently leading pioneering research that applies the core principle of explainable AI to biomedicine, redefining the trustworthiness of medical AI, from uncovering the molecular causes of disease to validating clinical AI systems. Now we will invite her to the stage. Please welcome her with a big round of applause.
감사합니다.
Thank you very much. In this special lecture, I would like to explain explainable AI. I will introduce the concept. In particular, I would like to talk about auditing and transparency and why these are important. And in our lab, we conducted our study. So based on that study, I would like to discuss what is the meaning and the importance of these technologies in the real world and medical sector. First of all, I would like to introduce the characteristics of biological and medical data, and I will also give you the background to understand medical AI. And I will explain why AI is very important in medical sector and why it is getting attention and what is explainable AI. And then I will focus on our studies in our lab to delve into why explainable AI is important. Last but not least, I would like to talk about the future direction of transparent, trustworthy, and auditable medical AI. In part 1, I will talk the characteristics of medical and biological data and why medical problems are inherently very complex. There is one simple example that shows the situation. There are two cancer patients and they have the same diagnosis and at the same stage and receive the same treatment. However, the outcome was totally different. This is very common situation. Then why do we see this situation? The reason is the cancer is not a disease. Depending on the genetic condition and microenvironment of the cancer and many other factors, the prognosis can be different. So on the surface, the disease can seem to be the same. However, the prognosis can be different depending on the patient. And it cannot be explained by just one reason, because there are multiple reasons. In this regards, there are multiple factors, and this life system is very complex system. And let's take a look at this situation more deeply. There are millions of cells connected together in our body, and there are many factors including genetic systems, and that is why we have different outcomes even though we have the same disease. And conventional medical approach cannot explain everything. So individuals are all different. Then how can we understand this complex situation in a systemic way? In this regards, I would like to emphasize the role of AI. To understand the biological condition of individuals, we cannot rely on just a simple data. We need to consider everything. Then what are the data? First, at the molecule level, we can see genes, sequence variation, and expression of protein. Humans have more than 20,000 genes, and medical data is enormous. For example, when it comes to the pathological images, it can include hundreds of thousands of pixels, and there are also CT and MRI and other medical records. And we also need to consider family history, lifestyle, and so on. So it is almost impossible to integrate all the data with the human intuition alone. And AI can analyze these data in a systemic way. How can AI address this problem? In an ideal scenario, we can input these enormous biological data, and model will perform numerous calculation and highly complex operation to produce the clinical information. For example, it could support cancer diagnosis and propose personalized treatment strategies. Then how AI can build and train the model. So there is a model, and model will adjust the parameter to be trained. And through this AI model can capture complex patterns and correlations in the data, and it can be very fast. Up until now, I explained the ideal situation where AI can explain the diagnosis, treatment, and prognosis. However, AI is not always correct. Unfortunately, AI is based on data, so there might be bias in the data, And sometimes there is a meaningless correlations in the data, and it can be trained. And correct prediction is not sufficient. We need to understand why this decision was made to apply this to patients. That is why we need to introduce the concept of explainable AI, or in short, XAI. XAI shows what is the ground for this AI decision, and we can identify the errors, and we can safely use AI. So this is a key technology. Importantly, XAI is not just for medicine. In all sectors where outcome of AI decision is important, XAI is essential because it can be a responsible technology. As for this explainable AI technique, one of the most widely used technology is SHAP. And SHAP is the technology we developed in our lab. So there are input, and we quantify the contribution of each input. The idea is very simple. We just sum the contribution from multiple factors and decompose it to understand what did the model consider important and why did it make this decision. Then let's look at the medical AI once again. As I explained, we can apply SHAP to the cancer detection or prognosis prediction model. Then we can understand what is the background for this decision. For example, we can see the color change of the cells and specific tissue patterns. And in prognosis prediction model, we can compare which genetic information such as clinical indicators and image-driven features played more important role. So medically important and meaningful signals can be verified. And through this explainable AI, we can go beyond prediction, and we can discover new biological mechanism to apply it into new therapeutics. In our lab, we study new XAI method, and we also worked to demonstrate how new XAI techniques can advance research in life science and medicine. In life science, we have led to new findings in areas such as Alzheimer's disease, cancer, aging, and genomics. And in medicine, we helped to understand and audit AI prediction and increase their potential for clinical use. And it was introduced in the cover article of journals. Now, we would like to move on to the fun part. Using SHAP, we can use various XAI, and I would like to show how it is used in life science, medicine, and how we were able to discover new insights. The first case is related to COVID-19 paper. After the onset of COVID-19, there were numerous articles related, and it applied CNN to see and predict the infection of COVID-19. However, in our study, we realized that internal testing was excellent. However, when other data was applied, the accuracy is lower. And this problem was caused because the training data was collected in a biased manner. So this basic explainable AI was used to explain this situation. And using shape-like method, we can compute pixel-level contribution scores for each chest X-ray image. And we can visualize this contribution score as a salience map, where the intensity of the red color shows how important each pixel was for the model when producing its outcome. For example, this transparent area shows that the model is predicting correctly. And at the same time, this model sees that the text is very important. However, that is not the intention. So there are edges of the images, and these are not relevant medically. This salience maps is very helpful for understanding what information the model was actually focusing on. And through this, we could explain why models malfunctioned when applied to data from other hospitals. In this way, we were able to prevent the research field from moving too far in the wrong direction. And it was published in multiple journals, and we proved that hundreds of related models have been incorrectly trained on a biased model. And on the following year, the Nature covered our study in a meaningful way. The significance of this work was highly appreciated. Simply put, the study proposed a framework for auditing how to trust AI in medicine and how to examine when and why AI might fail or become biased. So this was published, and the lab students were MD, PhD to become doctor and physicians. And they wanted to become the computer science as well, so they developed their career. And we are looking at the main cause of these errors. And I would like to introduce the next study. In this study, we analyzed the 5 models in total. 2 were academic models and 2 were commercial model. And we used the images of a skin lesion as an input. And in the internal testing, the outcome was excellent. However, we had the similar issue with the new data. So once again, we verified that we cannot fully trust these systems based on the apparent performance metrics alone. So first, we checked whether the commonly used existing XAI method worked well in this setting. And one thing is very interesting. The salience map shows that the entire lesion is very important. In this case, it is very difficult to know which specific feature of the lesion led the model to decide it is not cancer. And there is a limitation. So we need to go beyond XAI, and we tried a new auditing approach using generative AI by creating counterfactual images. So the idea is very simple. We modified slightly the original image, and in this image, you can see a blue-white veil is shown, which is the visual cue for melanoma. Then we can understand this model is using exactly this signal to classify the lesion as a melanoma. So to summarize, to audit one AI model, we first modified the skin lesion image so that the classifier would judge them as a melanoma or benign. And if we repeat this process, we can understand what kind of feature will be used for the model to be decided as a benign or a malignancy. And we analyze them one by one. As a result, we were able to verify the AI and do the audit using human-in-the-loop model. So we scrutinized the model's thought process itself. And we now analyzed how each system responds to various visual features and which features it interprets as indicative of cancer or not. In this way, explainable AI does more than merely explain a model, and it is a key technology that connects AI with the human experts. And it was featured in the cover of the Nature. And this illustrates how crucial the question, how do we validate trust, not just perform? So this study is just only one of many examples showing how counterfactual explainable AI can transform biomedical AI. And we also presented the vision and the direction for explainable AI-based medical AI in our journal article. And we are expanding our study furthermore. In the follow-up paper, we proposed a model when handling medical images. It presents its reasoning together with a text-based explanation grounded in the medical literature. So we solidify the links between images, text, and medical knowledges. And it was also featured in the Nature Medicine cover. We used a bimodal and a foundation model to understand the image, and it can also explain the knowledge based on the literature. And I would like to move on to another example, which is pathology imaging. It is very critical. The question is, how can we systematically represent and interpret pathological imaging? It is very complex, and it includes very complex and diverse morphological information. And it is heterogeneous. So it is difficult to clearly explain this. It is hard for human to manually specify rules for which morphological features are important. So we asked one question: can we learn more interpretable representations based on meaningful semantic concepts? So we developed our Picasso framework. So the key idea is decompose the complex pathological image representation into combinations of human understandable concepts. And it goes beyond a white box model. Now we can transparently understand. Let's be more technical. So after the training, we can see the input image, and after that, we collaborated with pathological experts, and based on the morphology, we conducted annotation. One of the key features is controllability, so we can control the AI model. So the model not only measures how strongly each concept is present in each image, but can also directly modify the original image by enhancing or suppressing specific concepts. So it means that there are a lot of downstream applications based on Picasso. So I explained explainability and verifiability. First, we create a morphological image, and downstream classifier will work, and we can audit whether it will work according to our intention. And specific morphological features can be connected to the molecule. And we can also lower the activation of the artifacts so that we can have more cleansed analysis. And we can also increase the level of lymph node. And we can do simulation in a virtual tissue. And we can also quantify the survival rate. So even before clinical study, we can predict the outcome of the clinical study. In conclusion, I would like to summarize what I said today. I believe in the future, medical AI should not be just a highly accurate prediction tool. We need to see what is the rate of failure. So, the AI system should evolve into explainable, auditable, and trustworthy system. And in the medical sector, accuracy does not guarantee safety and trustworthiness. So if we cannot understand why this decision was made, it is difficult to rely on the model in the clinical setting. Going forward, we need to look at AI not as a simple prediction model, but as an auditable scientific system. I would like to explain the future direction before I conclude my presentation. The core competitiveness of AI is not a bigger model, rather more trustworthy model. And explainability is not just a tool for nicely presenting results. Rather, it needs to enable scientific discovery and systemic model validation. So this is a foundational technology. So we need to move from black box AI to transparent and auditable AI. Through this presentation, I talked about explainable AI, trustworthy AI, and their importance. So it was very meaningful to have this opportunity. Thank you very much.
네, 의료 AI 새로운 패러다임.
So there was a presentation by Professor Lee Soo-in from Washington University. Please give her a big round of applause once again. Professor Lee gave us a clear and compelling account of why building AI that is not merely accurate but trustworthy and explainable is the defining challenge of the future of healthcare. Now let us move on to the next special lecture. We are honored to welcome a business leader who is providing Korea's extraordinary potential on the world stage in the global AI semiconductor market. CEO Park Sung-hyun of Rebellions will deliver an in-depth lecture on the topic, the dawn of the AI inference era, why the world should pay attention to K-NVIDIA right now. CEO Park earned his undergraduate degree in electrical engineering from KAIST, followed by a master's and PhD in computer science from MIT. He went on to build a distinguished career at world-class organizations including Intel, SpaceX, and Morgan Stanley, before founding Rebellions in 2020. Most recently, he successfully led the merger with Sapient Korea, marking an unparalleled milestone as the founder of Korea's first AI semiconductor unicorn company. Please join me in welcoming to the stage CEO Park Sung-hyun from Rebellions. Please welcome him with a big round of applause. My name is Park Sung-hyun from Rebellion. I'd like to thank the organizers of the forum for inviting me here today. Professor Lee Soo-in's presentation was really wonderful. And it was really good to hear her presentation in English. I sometimes use English, but my daughter told me that your English is elementary. Please kindly understand if I switch between Korean and English. So we just heard an academic presentation, and I'd like to talk about how the industry is accepting this new technology. For the next 30 minutes, I'd like to have your attention. Don't look at your stock prices. Some people say that we only need memory chips from Samsung and Hynix. We don't need to really nurture NVIDIA. However, if you look at the industry, it is not unidirectional. There are fluctuations, and it is critical that we look at how an industry should evolve. I'd like to examine the ongoing changes in the industry. If you look at the title of the slide, which summarizes the key message, even though there are concerns over hype, the AI market continues to expand dramatically, and we see many new players, and there are also many startups. If you look at the news like Bloomberg, there are a lot of concerns about AI hype. We have chatbots, but what are the other functions that AI can deliver? From the academia, of course, I started as a software engineer since 2009. So for more than 20 years, I've been working as a software engineer. So Claude is really amazing. Code assistants are better than me coding. We see continuous improvements, which is really amazing, but if you look at the size of the industry and TAM, we all know that there are massive amount of investments that are being made, but many wonder whether those companies will be able to monetize. By the end of the year, we will, I think, see. If you look at the market capitalization, which is continuing to grow, we will have SpaceX after the IPO. If anything goes wrong, we'll be able to see the opening of the hell. If they cannot find the solution for monetization, unlike before, SpaceX, OpenAI, they have a huge valuation. And they really need to find solutions for monetization because they have made a lot of investments for infrastructure, and they have plans for the future growth, at least for the next 2 or 3 years. But by the end of the day, after 3 or 4 years, whether or not they have secured the revenue pipeline, we will have to see. If you make investment, you should reap the results. Whether it's a hype or not, in 2022, we often heard that I understand or remember ChatGPT was launched in 2021. And there is this guy that I often saw on Bloomberg, and Skeptic's voice is quite loud. And there were many diagrams or graphs that were shown on TV. And those graphs on the screen showed something going up and coming down. I remember it was a time around the college students' summer vacation. But because we have a lot of chatbot traffic, but the physical AI and the other technologies, whether those can be used by everyday for all the citizens like we use Wi-Fi every day, we'll have to see. I would like to bring your attention to the red bar, the inference. What is training, what is inference, and reasoning. In Korean, inference and reasoning are same, but actually it is not the same. But I would like to say inference is more of serving. Inference sounds like it is called 추론, but it really sounds super complicated. But it is about, without changing the parameter, using the model. And before you compete on the Olympics, you train yourself. And training is about like training the parameters, but when we talk about inference, so instead of using the Korean word, the same Korean word for inference and reasoning, we will have to, I think, better to use the English words inference versus reasoning. We have significant startups that are making foundational models, and inference is about using the model that's already created. Inference is quite challenging. Probably you're familiar with using Claude. You ask questions and it provides answers, and that's inference. Training is similar to research. As people use more AI tools, traffic goes up and competition will increase. And if you look at the process of inference for a company like us, as a semiconductor chip maker, I understand that you don't learn about this. Some of you did not learn the matrix. AI looks quite cool, it's hot, but if you look at the primitive, it is actually a matrix, a modification. So we need to be really good at matrix modification. That's the green inference market on the slide. If you look at the market size, quite sizable. We are now seeing the switch from the training market to the inference market. We have major players, or we have doctors or Go players, higher skilled personnel using it, but my mom, my dad, and my grandfather can use these AI tools, and then we will see the green part or the inference market to grow further. That was not my expectation, but it is from Bloomberg. It will become the biggest semiconductor market. It will be the biggest market in human history. In the inference market. AI computation, AI is something we often talk about. It can mainly divide it into training and inference. And in inference, which is serving using the existing models, the market is growing and it will become the largest segment ever in human history. So something big is coming. So I'd like to now talk about rebellions, what we do. We are not better than NVIDIA, but we make chips for inference. I have a great respect for NVIDIA in terms of functionality. NVIDIA is much better than us.
Computation that includes, how can I say, Bitcoin mining, graphics rendering, training, and lots of inference. 어마무시하게 많은.
It boasts flexibility and functionality, and allowing all of that on a software platform is just amazing. That's why NVIDIA is #1 in terms of market capitalization. And NVIDIA ecosystem has been created.
Interconnect, InfiniBand라든가 이런.
Training and inference parallel computation can be possible using NVIDIA. However, Rebellion is focused on inference. Our chip does not allow training. It is not for graphics rendering or Bitcoin mining, but at least in terms of inference, our chip is quite good.
Energy efficiency and much higher cost efficiency and performance simultaneously. 즉 선택
So we have focus, we are cost effective, and we are energy efficient. Of course, token per second, the performance, TTFT, those measurements, there are different types of metrics, but we're focusing on the inference market. We are not interested in other things, but within the inference area, we want to have a good performance, and at the same time, per watt per dollar. The efficiency is another area that we are focused on.
just within 3 years, we've got merged with SK Sepion. Right now, we are more than 3 billion company within 5 years. 이게 저희가 뭐 위배
Of course, we've been working really hard. But as with the rest of the industry, we had a really good headwind that spurred our growth. And for the next 3 or 4 years, if AI can monetize or companies can monetize, and if the massive infrastructure investments can be justified, then rebellions can be something that could be called a K-NVIDIA. Now, of course, this is a comparison between training and inference, different use cases and decision makers. From the compute granular perspective, inference is a subset of training. It's a very small subset of training, so it's specialized and focused. But optimization methods and software ecosystems are different. From the training point of view, the interconnect software flexibility is not required. The CUDA-based optimization is not used, rather VLLM, Torch, PyTorch, and software ecosystem is different. This is not what I say, but OpenAI ChatGPT does not use CUDA. We use open source ecosystem. Intel CPU used to be, this is too specific maybe. Intel used to be a startup, but now it has surpassed IBM and Google. I don't think Intel has a good CPU. Intel CPU was not good enough to beat IBM. Rather, the Intel software, the Linux movement, I think it was a Linux unit. It did not use a closed system, rather it used an open source Linux. Our vision is we see or expect a similar Linux movement in inference market. In the inference market, I think PyTorch 2.0 movement will, I think, begin a new chapter in our industry in the inference market. So that Linux movement will happen, I think. So in the inference market, I think we can play a really different game. That's what I think. Energy efficiency is really important. When we talk about energy efficiency, often people think about the battery life of your mobile phone because you want to have your phone to be used at least for a full day. But not just in mobile, but in data centers, energy efficiency is really critical. Whenever somebody talks about data centers, we used to talk about this data center is tops or flops. But instead of saying that, this is a 1 gigawatt data center or this is a 4.3 gigawatt data center. This is our edge data center. It's a 40 gigawatt data center. So when we think about data centers, we don't talk about the compute capacity, rather we talk about the energy consumption of data centers. So it is not compute bound, it is power bound. And we are now going through the period of where the memory bound is important. And at the end of the day, it's going to be a power bound infrastructure. Whether we build something in New York or Wyoming, even though in Korea we don't have sufficient land, however, we need to think about if we are building something in the US, we have to make sure that we have a stable supply of electricity. We also need a software ecosystem that can orchestrate everything that goes on top of the platform. And whether it's a vision, whether it's a really concrete or messages, we need something that we can secure stable energy supply. Maybe we will have space data centers. I know some things about this because I worked at SpaceX. So it's land bound, power bound, and resource bound. What's really important is power. If the Earth cannot provide sufficient amount of energy, then we have to find solutions in space. That's what's happening, and that's what the SpaceX is doing, and it is a key investment message for the upcoming SpaceX IPO. Data centers are power-bound. Energy efficiency is critical. When we talk about tokens, there are daily token production amount. Some say I used tokens 10 to the power of 4. For the end user's point of view, the token price is critical. And considering the capex and opex, how much energy is used to generate a token is important. So what we are focusing on is not the total performance. In terms of token per second, NVIDIA is better than us.
Way bigger chips. The token per second, just absolute performance만 놓고 보면.
Looking at the absolute performance, Cerebras is better than, I think, NVIDIA. But if we look at per watt and per dollars, based on capex and opex, if performance is divided by the energy consumption and per dollar and per watt, rebellions compared to NVIDIA, we outperform NVIDIA by 5 to 7 times in price performance per unit of power. If you are interested in graphic renderings or Bitcoin mining, our chip is useless. However, for multimodal inference, and if you're also seeking energy efficiency and cost competitiveness, at least when it comes to price performance per unit of power, we are better at least 5 to 7 times. Now there are customers using our chips for that purpose and for that advantage. This is really technical, but I really wanted to touch upon this slide. Before founding Rebellions, I heard a lot of things about CUDA. CUDA is really techy. Low latency programmers or those who develop robots use CUDA for programming. But what we do is actually pick up. But I've been really, when often OpenAI does not, for serving, they use Python and PyTorch 2.0 and VLLM and SUGN. But here, online training in inference, open source software, and open source ecosystem is the new way. Similar thing happened in the past. When Intel outperformed IBM, when they had the Linux movement, the similar thing happened. There was a perfect abstract layer. So we know about the hardware, but can we move on to the software ecosystem? Yes, because this abstract layer is being created, software ecosystem should have backend compiler and system software and other things. However, if the ecosystem is created, then we will have the Linux movement, something similar like that will happen. For software developers, they're fixing all this, which is really amazing. Like Linux, Red Hat-based developers, they all know open source wins. We cannot really explain why, but that's what's happening, and that's what happened before. When I was in graduate school, studying in the graduate school, there is what's called a Stack Overflow. I really worked hard because even though nobody paid for me. So there are a number of open source platforms competing, and in the area of inference, they are working together. Of course, we have these significant players that are competing against NVIDIA. These are not small companies. We have Amazon, Google, Microsoft, Azure, and we have startup SIEM and hyperscalers. Of course, they don't want to be locked up in NVIDIA ecosystem. I'd like to talk about interconnectivity. NVLink has really good performance and efficiency, but it's based on Ethernet, which is open source. Because they don't want to be locked in NVIDIA. That's the hyperscalers don't want to be locked in. In the computer industry, companies have been locked in training. However, it is not the case in inference market. So proprietary software stack is used. We bring the good branch, and you don't have to be locked in. Optimization can happen. The framework can be updated, and you have no option to do anything else. But if you have an open source ecosystem and really want to pursue open source, Cerebras, NVIDIA, Grok, Tensionland, these companies, they are first generation startups. They have their own proprietary software stack. We have Torch.compile, and we are really focused on open source based hardware and software ecosystems. I have only 2 minutes left, unfortunately. We can save 30% of 40% of power consumption because we know how to do it. And a lot of hyperscalers like Apple and Samsung are making their own chips. And then they can save more power because they know. So PCI card server rack scale solutions. Here you see in data centers, power efficiency is really important. So there is a call recording summarization app made by SK Telecom. And they're recording 50 million calls per day. It's like Big Brother. They're recording all the phone conversations. And Korea's first NPU as a service is now utilizing our chip at KT Cloud, and we have also collaboration with Aramco, and we now have Korea's first rack scale AI infrastructure deployment. I have 1 minute left. Unfortunately, here, as you see on the slide, Who are friends? Who are foe? We are not sure. Sometimes you know TSMC, you know Samsung Foundry. If you're interested, you know and if you're also interested, you also know Synopsys and Cadence. This is a semiconductor is all about ecosystem. If something goes wrong, we cannot move forward. But TSMC wafer, Samsung wafer, SK Hynix HBM, these are critical. But NVIDIA market share is the biggest because NVIDIA does the allocation at the end of the day. So we have this massive ecosystem.
Friends. 누가 적이고 동지인지
I don't know who's my enemy or who's my friend. We see a lot of changes happening in the market, changes in relationship between different companies. I recently heard someone say that somebody who has the money is my friend. So here, what's really important is who has the money, who can lead the ecosystem. In the software and hardware ecosystem, maintaining the ecosystem is really important, and rebellions, more than anyone else, really want to be part of the ecosystem. We have partners and strategic investors, SK, Marble, ARM, and these companies have made investments so that we can create the ecosystem. We became the first company to be included in the National Growth Fund, and now we are branded as K-NVIDIA by the Korean government. We are a company that focuses on the infrastructure market. We also focus on, of course, we want to make a good performance, but we also focus on the energy efficiency. If infrastructure is commoditized, efficiency and price competitiveness will be important in the next 2 or 3 years. I am sure there will be standing shoulder to shoulder with NVIDIA. We will be competing on the same stage with NVIDIA, and we continue our work so that we can dominate the inference market. That was a brief introduction of Rebellions, the company, as well as the industry. That's the end of my talk. Thank you very much for your attention.
네, 고맙습니다. 리벨리온 박성현 대표님.
Thank you very much. Please give one more round of applause to CEO Sung-Hyun Park of Rebellion. I am leading an economic program and business program at Seoul Economic TV, and I study semiconductor a lot. And inferencing market has huge potential, and it will be bigger in the future. So I think I got a lot of insight from this lecture. As he explained, this is the first direct investing company of the National Growth Fund, and I hope that you can work harder to grow the company. Then we would like to move on to the session 1, which is entitled The Redesigning Industry, the Physical Revolution Driven by Robotics. And the first speaker is a distinguished scholar who has earned global recognition in the artificial intelligence and robotics. He is currently a chaired professor in the School of Electrical and Computer Engineering at Cornell University and a fellow of IEEE and AI. And Professor Daniel Lee will give a talk on a white box model and neural geometry. Please welcome him with a big round of applause to the stage.
안녕하세요.
Good morning.
This morning I want to try to address the following question. 인공지능을 어떻게
How can we understand artificial intelligence?
systems and how can we use that understanding to try to make better AI for physical AI in the future? So that's a question I want to address today. So what I want to cover is to give you some context about how we got here in terms of AI and robotics. How do we understand what we're using today in terms of these very large systems? And we want to be able to look, like Sue-In explained in her talk, we want to look inside the black box models and to understand the representations inside AI. And in particular, we want to use mathematical tools, geometry and statistics, to be able to understand what's happening so that we can design better AI systems, especially for safety critical systems in the future. So that's what I want to try to cover. So first, I want to give you a brief overview of the history of AI. 먼저 인공지능의 역사를
I would like to talk about the history of AI first.
When AI, the first wave of AI was in the 1980s, everyone concentrated on writing down logical rules that we would build into computer systems. And this, didn't work very well, so that led to, in the 1990s, what's known as the AI winter. So for the researchers who were working on AI at that time, AI became a dirty word. If you said AI, no one would give you any money and you were shunned. This was a time in the 1990s. Then we started to see a revival in the 2000s where we became to use what's known as statistical machine learning techniques. That means we are going to be more data-driven than trying to write down rules for AI. And this exploded in 2010. This was the deep learning revolution, where the data and the models became much bigger. And now, here today, we're in the generative AI era, where these systems are extremely big. So, where are we going to go from here to the future? Well, the big, reason why we're all here is that there has been many successes in AI, starting from games, chatbots, image generators. We all know kind of these applications. 성공이 많아요, right? There's many successes. So let's review kind of, what happened in the development of some of these AI systems. So let me give you some examples of things that I've worked on over the years. So the first example here is AI for autonomous driving. So, what we want to do is to build a car that could actually drive itself using AI and sensors. So this is something that we started 20 years ago. Let me give an example of what this looks like, right? This is an AI system, and it's driving the car by itself. It's using AI to do object recognition. It's trying to sense, other cars in the area, and it's trying to figure out, when it should turn right, when it should turn left, when it should wait. These are all the things that we tried to build into these systems. Now, at that time, 20 years ago, this was just an academic research project, right? No industry, no companies were interested in this technology. But what we've seen now is that this kind of use has exploded, right? Every country, every manufacturer, car manufacturer has an autonomous driving effort. They're trying to sell you this service where you can basically rent a car using autonomous driving to be able to get from point A to point B. So we've seen the growth, this incredible growth of AI in the physical world, especially in this kind of autonomous driving scenario. So 로봇들이 운전할 수 있습니다, right?
Robot can drive the cars.
Let me give you another example of AI in the physical world. This is humanoid robots. So 15 years ago, my students worked on actually having humanoid robots learn using AI how to play the game of soccer. So you can see here, this is what those robots looked like at that time. These little humanoid robots had to learn how to walk, how to find the soccer ball, how to coordinate between themselves, be able to pass the ball, being able to kick the ball. You can see here in this video, our robot team going against another robot team, humanoid robot team. Our robot here makes a kick. The other team's goalie makes a save, right? What happens then is you can see that the robots are not very sophisticated at that time. The goalie gets up. The ball is sitting there in front of the goal, and our humanoid robot is able to get to the goal, get to the ball, and kick the ball into the goal for a score, right? So that's what it looked like at that time. What we have today now is you can see, right? These are humanoid robots today. They're, these incredibly sophisticated hardware that can do these scripted motions very, very well, right? These kind of dance maneuvers. You can see these robots from Unitree being used in a Lunar New Year show in China. So this is kind of where we are today, right? Humanoid robot도 축구를 할 수 있어요. We are able to play soccer, we can dance, we can do these things. However, we still don't have a robotic butler in your home. So we still need to make progress to be able to make that kind of technology happen for daily life use. Another final example here is drones. So this is an example of some of the students that I worked with. At that time, 15 years ago again, we developed our own homemade drones, and we used AI techniques to figure out how to control the drones to fly and to be able to coordinate their actions. So this is what it looked like at that time, 15 years ago. This is in the lab, being able to use homemade drones. The students built them by hand. DJI did not exist at this time, right? They're able to then coordinate the actions to make these formations and to be able to use AI techniques to try to plan and to be able to actuate in real time these types of systems. So this is what we had, back then. And now what you see is the development of these techniques has led to the following, right? This is actually a short video showing a drone show over the Han River this past year in Seoul, Korea. And you can see now that they just scaled this up. Thousands and thousands of drones being able to make formations that show, K-pop singers, whatever you want in terms of kind of a real-time show using these drones. So 로봇들이 새 때처럼 날아요, right? They're able to fly like a flock of birds. All right. Okay, so what makes all this possible? What's possible today is that we have these large neural network models involved in the control of these robot systems. Okay? So whether it's a kind of deep convolutional neural network or a transformer model, all these systems have lots and lots of components, these neurons, that are then cooked together and trained using data from these systems to be able to make their perception, to be able to make their world modeling, and to be able to take actions. Right? This is what's involved with building these systems from an intelligence point of view. Now, what we know is that these systems have the following virtue, right? Right? The idea, whole kind of lesson that we learned in AI is the power of scaling. What this means is that the more computers that you use, the more data that you use, the bigger the models that you use, you'll get better performance, right? The bigger, the better. The 크면, 더 좋아요, right? This is the bigger, the better. So this is the basic lesson that we've learned. So how do we understand this fact, and can we continue to do this type of scaling to continue to build up to real physical AI systems? That's the big question I want to address. Now, the issue with scaling is the data. Especially in physical AI, the data is very limited. So if you think about for AI systems, where does our training data come from? It comes from humans, right? Humans have kind of written down things. Now, the problem with AI today is that we've basically used up all the data from humans in all of human history. Now, the problem is that human populations are not scaling like Moore's law. The human, right, as we know in South Korea, the population has saturated and is going down even. So the kind of future means that data generated by humans will saturate. So we need now, instead of just scaling up these systems, at some point we will have to be more intelligent about how we build these systems in order to get more and more performance out of them. So this is really a fundamental question, is can we actually get better understanding of these systems so that we can actually scale better? Here's one example of something that happens when you try to scale a neural network system. This is something called the double descent phenomenon. So traditional statistics tells us that when you scale a neural network model, an AI model, typically as you get bigger, it starts to get better, but at some point, it starts to get worse. This is something known in machine learning as overfitting. But what happens with AI systems, some of these AI systems, is if you initialize everything properly, if you use kind of exactly the right learning rule, then you'll, besides getting worse, at some point it starts to get better again. So this is what's known as double descent. Now, theoretically, this is very difficult to understand. So if we really want to use this phenomena to train our systems, we better have a better fundamental knowledge of what's actually happening in an effect like this. And then we can use this to try to train better systems, right? So this is, the idea here is 이 행동은 이해하기.
So this behavior is very difficult to understand.
So how can we make progress in understanding? So the way we think about these systems from a mathematical point of view is that we have this incoming data, we have these signals. You can think of simply like an image coming into your AI system, in a physical robot using its eyes. What you can think about is each pixel of this image as a component of what we call a vector, a high-dimensional vector. So every possible image is a point in this high-dimensional vector space. And then what AI has to do is somehow analyze all these different vectors, these points in this high-dimensional space, and figure out, for instance, which points correspond to dog images and which points correspond to cat images. This is at a kind of a basic mathematical fundamental level is what happens inside a neural network. Okay? So what we have here is kind of the most fundamental basic model of what a neural network does. What does an artificial neuron do? This is something called a perceptron model. It was invented, back in the 50s, and it tries to model what happens inside a neuron in a neural network inspired by biology, what a biological neuron does. And the idea is it takes some input, multiplies those input signals with these neural network weights, neuron weights, and it outputs, a simple signal outside that says whether whatever happened coming in is true or false. That's kind of the basic fundamental model of a neuron. So in this case, this one is a neuron의 기본 모델이에요, right? It's a very basic model. But we want to understand what this model is capable of doing. So what we have to do is, from a mathematical perspective, analyze, what a single neuron can do. And you can think about this as analyzing at the last layer of a neural network what happens. And in the last layer of a neural network, you have these points coming in, right? Your input signals. They get, moved through your network, and at some point they have to be classified into, say, a dog or a cat or an obstacle or a road, right? These are the things that you need to classify in your inputs. So what we need to do is focus on the capabilities of these neural networks, and we focus on separability. How can we, basically separate these different inputs from each other? Okay, so this is a fundamental concept in understanding these neural networks. And there's a nice theorem. This is made by Tom Cover, who's a famous professor from Stanford, information theory. And he wrote down a nice rule that told you exactly how many different points a neuron, a perceptron, can classify into two different classes. These are called dichotomies, given p points and n dimensions. Okay? He wrote down a nice formula for this. It's a theorem, and it's the same as actually being able to count how many slices you can cut in a pie in n dimensions. So for example, in 2 dimensions, if you take an apple pie, if you cut one slice in it, you make 2 pieces. That's like doing 2 dichotomies. If you actually cut a second slice, you can make 4 pieces. Okay? But if you make a third slice, it's impossible to make it into 8 pieces, which would be the maximum number possible, right? Instead, you can only make 7 pieces with a third cut. This is exactly the formula that describes this is exactly the same that describes what's possible with a neural network. Okay? This is called the capacity of the system. All right? So what you can then see is that we have then a nice mathematical formulation of how much a neural network can do in terms of the number of points and the dimensionality of the system. And what happens here is that we see that if the number of points, according to Cover's theorem, if the number of points is less than twice the dimensionality of the system, you can basically always classify your data properly. And if the number of points is greater than twice the dimensionality, you can never classify your data properly. So there's a nice, what we call a phase transition in understanding a neural network. Okay? So this is why we build large neural networks. We want to go to what's called a high-dimensional feature space where the neural network has more capacity, and then we can use this capacity to do this kind of more complicated classification and regression and basically decision-making in these high-dimensional spaces. So 많은 치수가 필요합니다. We need these high-dimensional spaces to make this work. So this is what you can see from this analysis. But what happens when we go to infinite data? And this is what AI people do. they take an input and they basically do this kind of transformations on it. It's called data augmentation, where we take all these inputs and we turn them into many, many other inputs. And so by rotating things, by scaling images, by changing the inputs, by language, by modifying the language a little bit in LLM, we're doing this data augmentation, and that means that the number of input data we're actually taking to infinity, right? So muhan-dero, right? We're going to infinity. So how can we understand this limit mathematically? So what we've done is to try to come up with a mathematical model that can explain when we take this infinite data limit, what we do is we model this infinite number of points. Instead of as points, we think about them as what we call manifolds. They're basically geometrical structures in this high-dimensional space that have kind of volume and surface area. And so we want to model the data using these manifolds to be able to explain what happens into these systems. Okay? And there's something in AI known as a manifold hypothesis, which is saying that what neural networks and AI does is they take input data, which has very complicated manifold geometry, and what they learn to do is they simplify the geometry through the neural network so that at the last layer of the neural network, it's a simple geometry that can be easily classified or made decisions. So this is really kind of a fundamental understanding in terms of trying to understand what a neural network does in terms of the underlying geometry of the data system as it goes through the different layers or through the transformer of this neural network. So, to summarize, what the manifold hypothesis says is 복잡한 기하학부터 단순한 기하학.
From the complex manifolds to simple manifolds we can make.
Do this properly. What we have then is we can then, instead of classifying points like I told you about in the traditional theory of neural networks, we can think about how much we can classify manifolds from each other, right? This kind of infinite data limit. We can try to classify and understand when that is able to occur. All right? And that's really then described by geometrical quantities. So we can understand what a neural network does using geometrical tools, mathematical tools, to understand what happens to the structure of the data within these very complicated AI models. So you can reduce things down to things like radius, dimensionality. These are the kinds of things that you learn in mathematics that you can then apply to understanding what happens in a neural network. Now, I want to now explain why we would want to do this, right? What we know now today is that the kind of traditional test of intelligence in AI, it's known as the Turing test, is basically what's known as a black box model test of AI. You just give AI an input, and you look at its output, and you try to see whether that output is correct or not. Now, what we've seen today is that we've come to the limit of what a Turing test can tell us about AI, right? We've seen that, in many cases, AI model can do just as well as a human in terms of the Turing test. So what we want to understand is, can we do more than this? How can we evaluate the quality of an AI model beyond just this kind of input-output relationship test? And there's many reasons for this. There's many philosophers that talk about, well, how do you measure really intelligence? There's a kind of paradoxical types of arguments about why the Turing test is not complete. So these are the things that we want to get beyond. So in order to do this, what we need to be able to do is open the black box and look inside what's actually happening inside an AI model. And that's what I call a neural representation, right? I want to see inside the AI model, look at the different neurons, and see what the representation of the data looks like inside the model itself. And that's how we can make better progress. So in order to do this, right, we have to take these neural representations, and we have to now use mathematical tools to analyze exactly what the structure of these representations are. And if we can do this, we can understand not only AI, but we could try to understand better what's happening inside your brain, what's happening inside an animal's brain, say in a dog brain, right? And then be able to compare different AI models with us as humans, and also compare with other forms of animals, right? So where exactly does an AI model sit in terms of how it represents a particular task? Is it more similar to a human? Is it more similar to a dog? Is it more similar to another model, right? This is the kinds of questions we want to address by analyzing these representations. So what we do then is we collect this data, right? You can then measure. In biology, you would go in and measure the neural activity as you put different stimuli into the system. And we do the same type of analysis with AI, right? We probe basically what happens when you put different stimuli into the system. You look at the neural representations, and then you try to measure these types of geometrical types of features that I told you about that can describe how good is the AI at transforming the structure of the data in this particular task. Right? And in this way, we can actually then try to understand, the differences between different animals. We can go in and measure the geometry and different brain structures in different areas of the brain. And you can then apply these kind of statistical tools, mathematical tools, to then try to build more efficient types of AI models that could actually handle this data properly. Right? So with these types of analysis and kind of techniques, we can look inside the brain better. So 뇌 속에 이해할 수 있습니다, right? We can try to understand what's happening inside the brain. So this is really then, I think, the future, right? So this is kind of the analogy I want to make. Today in AI, with physical AI, we're kind of like what Sigmund Freud did, right? Sigmund Freud was trying to understand human behavior, and he did it by just analyzing, looking at people's behaviors and dreams, and trying to infer what's happening inside you in terms of just looking at your dreams and your kind of behavior. Now, as we know, Freud's theories are very incomplete and doesn't really describe behavior. So what we need is kind of a change in philosophy, and this occurred in terms of the development of neuroscience. So Ramon Cajal is known as kind of the father of neuroscience. He was the first one that, instead of just thinking about human behavior, he was the first one that actually probed and looked at actual neurons in the brain and tried to discover how the brain works by actually mechanistically looking at the neurons. So in the same way, what I would like to try to see in the future is that we can use these kind of techniques to try to really understand how AI systems are built and operate, and then we can actually use them to make better AI systems by this kind of interpretability and understanding of what's happening inside an AI model. And in this way, I think we need this to guarantee the safety and performance and robustness of AI for actual physical AI. And this is very important for the future. So let me conclude. So what we've seen is that the current AI systems are approaching the kind of infinite data and model size limit, right? We're really approaching saturation in many aspects. And if we want to make further progress, we really need to kind of understand better the inner workings of these large neural networks, right? Instead of using psychoanalytical techniques, we need to use basically neuroscience, MRI types of techniques to look inside what's happening in these AI systems. And in particular, we need analysis tools that are based upon kind of fundamental scientific techniques, geometry and statistics, to understand how we can then develop and improve these systems for the future. So thank you very much for your attention. 감사합니다.
네, 고넬대학교 전기
Professor Daniel Lee from University of Cornell, thank you very much, and please give a big round of applause. Professor Lee explained the automatic mechanism, and he is a leader in combining this technology with engineering. So I believe he presented very interesting examples in the presentation. So the focus is not the output, rather internally, what is happening in the model is the key. That is the key message of the presentation. And he also explained that there is a high-dimensional geometric structure in the model. So the white box approach will be applied in the future AI model designing. Eventually, when we have bigger AI, we need to have a greater role of mathematics and statistics. That is the key point of the lecture. And I hope that you got a lot of insight from the presentation. So we completed two special lecture and the first lecture of session 1. And moving on, we would like to have a panel discussion.
The topic of session 1 is related to industrial redesign and the physical AI revolution made possible by AI. So let us begin the panel discussion session of the first session. This panel discussion will be moderated by Professor Hong Sang-soo of Seoul National University. Please welcome Professor Hong with a big round of applause. Professor Hong is one of Korea's most prominent scholars, having pioneered the fields of real-time embedded systems and future automotive software in Korea, and is a full member of the National Academy of Engineering of Korea. He applied Korea's first real-time operating system, Velos News, to the T-50 advanced trainer aircraft and led the commercialization of Samsung Electronics operating system SMK. He currently serves as chair of the AI Future Mobility Subcommittee under the Ministry of Trade, Industry and Energy's Manufacturing AX Alliance, where he is spearheading Korea's AI transformation strategy for the manufacturing sector. I'd like to also introduce the panel discussants. Michael Perry, Head of Commercial Strategy, Persona AI, Daniel Lee, Professor of Cornell University, Song Ki-young, CEO of Holiday Robotics, Jang Han-young, Head of Physical AI Lab and CAI, Ko Hoon-kwon, Senior Research Engineer and Head of Group, Mobile Robot Solution Group of Hyundai Motor Company Robotics Lab. So we have the panel discussants on the stage. Please welcome them with a big round of applause.
네, 그렇다면 이어서 우리
Now I'll hand over the mic to Professor Hong to moderate the session. Good morning. I'm Hong Sang-soo from Seoul University, Seoul National University. First, I'd like to thank the organizers of the forum for inviting me as a moderator for this important discussion session. I think it's a really important day and it's an important session. And as a moderator of the first discussion session, I'll do my best. So the title of our talk is The Physical Revolution Led by Robotics. As you all know, companies like Palantir is applying AI in many different aspects, increasing productivity. And also robotics is another important area or application where AI can be applied. Of course, we don't want to restrict our discussion to robotics, but we can expand into other topics. So we can talk about the overall physical AI. But the key focus will be, of course, robotics. As was introduced by the MC, we have Professor Daniel Lee and Mr. Song and Mr. Zhang from NCAI, Mr. Go from Hyundai Motor Company Robotics Lab, and Michael Perry from Persona AI. I'm not going to give any more additional introduction of each of the speakers and panelists. I think this gathering is really meaningful because we have experts with different backgrounds, and it is a rare opportunity to have them at the same time on the stage. We also have an audience. Some of you have expert knowledge, but others also may have a lot of interest on the future that can be brought about by AI and other technologies. So I've been thinking about how I should moderate the session, and this is what I decided. First of all, we'd like to examine the physical AI application in different areas, and I'd like to ask the panel discussants to talk about whether the evolution of the technology can benefit the human beings. I majored in automobiles technology, and whenever I attend an expo in China, I see many Chinese companies swiftly working to apply AI technologies in automobiles. So I know that there are many companies competing with Chinese companies, and China and the US are quite the leaders of the physical AI space. Also, sometimes we only focus on the continuous progression of the technology. And when we had the first Tesla, we had the door handle that is embedded on the car frame. However, that was made illegal by the Chinese authority. And when accidents happen and when the electricity supply is cut, sometimes the persons inside the car cannot escape the vehicle. So we saw the company going through a lot of trials and errors. Maybe we can think about the trials and errors that we are seeing in the physical AI development. So we will now begin the panel discussion. I'd like to start with Mr. Perry. Maybe you can start or provide some comments on the overall topics that I just introduced. We have 100 minutes for this panel discussion session. However, we started a little late, so we have about 90 minutes. But we also hope to see whether there are any questions from the participants. So I'd like to save the last 10 to 20 minutes for a Q&A session. So I'd like to hear from you, Mr. Perry, about the overall theme of this panel discussion session. What are your perspectives on the robotics in the industry?
Wow, what a big question. Lots of different angles to highlight here. Maybe starting off with the question that you asked is would robotics help people? I don't think the question is, will it help people? The answer is, it must help people. The reason for that is a fewfold. One is that we have urgent problems, whether that's in healthcare, manufacturing, sustainability, that can only be answered by supplementing our current physical processes using next generation robotics. So the fundamental question is not will this happen, but how does this happen in a way that is valuable, thoughtful, and safe over a long enough period of time. Some of the highlights that you mentioned during your talk was about the differentiation between, the progression in Chinese and American physical AI development. And it's very easy to look at the incredible videos like Professor Lee just showed from China. There's Chinese New Year, Lunar New Year celebration, and infer that in the next year or two, because robots are doing backflips and doing incredible wuxia routines, that we're going to have a robot butler in the next few years. But there is a fundamental challenge that Professor Lee can expand upon more than I can, called Moravec's paradox, which is the concept that something that's very easy for robots is very difficult for people. But on the other hand, what's really difficult for people, what's really easy for people is really difficult for robots. And so when we look at a robot doing a backflip and, you know, doing all these incredible things, these are control systems problems that these robots are optimized for. But the very, you know, basic things that we do today, like picking up this microphone and twisting my body and picking up this bottle of water and knowing exactly what I'm doing at each time and doing it safely, is incredibly difficult for a robot to do. So we have to base ourselves in what robots are actually capable of doing today, and then start plotting out a realistic course for sequentially how it's going to add value over a longer term. There's a lot more to dig into here, and you know, Professor Lee can dive into the details. But the one last thing to highlight here is safety. One of the biggest challenges that we often see is the desire to accelerate the adoption of the technology, either because of a need or sometimes because of the market incentive, because you know, your valuation will go up faster if you deploy robots and you say you're a physical AI company. That all has to be grounded in the human safety of these systems to make sure that they're safe to use in their environments and safe to operate around. Too often, you see companies accelerating the use of robots in environments and use cases where they could cause real physical damage to people and the work environment that they're in. Developing and implementing safe standards might slow down the initial progression of robots into industrial spaces and in some of the useful workflows that are important for us. But it's going to be critical for us because without these safety guardrails, without processes to keep people safe, working close to and side by side with robots, the technology will never reach its full potential, either both in terms of the value that it creates or the economic incentive. We'll probably dive into some of these things further on, but I'll pass it to Professor Lee.
I also agree with Michael that
네, 저도 동의하는.
area where we have lots of promise, but there's also a lot of hype today. So we need to kind of keep grounded in terms of what's really possible now, what has to be developed, and as Michael said, you know, what's kind of the proper development of these things to make sure we have everything safe and robust and verifiable. So this is really, you know, kind of still a lot of research to be done. I think a useful case study of physical AI is, say, the field of autonomous driving, right? So, you know, Waymo, Tesla, they, you know, starting 10 years ago now, they were promising autonomous driving systems at full autonomy. This is level 4 automation, which means that, you know, the human does not touch the wheel. And a computer and a robot will kind of take you anywhere you want to go in the country, right? That was the promise. Now, that hasn't happened yet, right? There's still a lot of edge cases in autonomous driving where AI is not good enough, right? Where, you know, there's a construction zone, or, you know, they rerouted roads a little bit, or, you know, if the communication system is down a little bit so the servers are hard to reach or latent, you know, there's high latency, then these systems fail. And so we haven't really reached the promise of autonomous driving even, as opposed to even like having robots in your house doing things. So that's even a harder problem. But autonomous driving is kind of a case where we have actually lots of data, right? We have collected lots and lots of examples of robots on the road. We have, you know, huge data sets. We're then trying to train these things. And what we're finding is that for kind of proper use and safety, the kind of edge cases always come in the way. And that's why, you know, when you drive, you know, using a Tesla or a Google Waymo, you still have these situations where basically the AI stops and a human has to intervene to basically save the robot in that situation. So this is really, I think, a good, useful kind of a reminder of the challenges still, and to kind of, you know, tamp down a little bit of the hype and to be able to then think carefully about what's really needed to really make good progress and to build these systems in the future. And that's why I think we could also discuss a little bit of that road, that kind of a timeline. Thank you.
다니엘 리 교수님께서
So Professor Lee you actually provide some answers to my next question. But I'd like to ask further question. My question is, so we still have a lot of hype concerning robotics, but as a person who's developing robotics, Mr. Go, from your perspective, how do you see the reality on the ground? Do you think we have a lot of AI robots that are really working on the floor, shop floor? So please kindly, Mr. Go, explain. Hello, my name is Ko Hoon-gon from Hyundai Motor Company Robotics Lab. Boston Dynamics Robotics Lab exists under our company, and I am associated with the Robotics Lab. So according to your question, so how much AI or robot technology are being used right now in the field? Robots have certain functions, and those functionalities has been demoed. And now we see some application that is possible, and that's what we are also researching, so that we can deploy robots in the field. We should make sure that robots should be able to perform some tasks, and the level of performance should be good enough, and that should be validated in our lab. We use mathematical models to allow the robot to perform the task, but we also use AI technologies, and many techniques have been applied to allow the robot to perform many tasks. And we are creating the environment to obtain data, and based on the data collected, we will see how much the actual deployment can happen. So we see a lot of things that are possible through demos. However, those demoed features or functionalities cannot be deployed in the field.
그러면 이어서
Thank you. Let me move on to the next panel. Mr. Kyung-song from Holiday Robotics. Hello, I'm from Holiday Robotics, and my name is Kyung-song. First, our focus is commercialization of humanoid. Humanoid for home, or humanoid for restaurants or clinics would be our final goal. But our first step would be industrial fields such as industrial shops. And we are developing humanoid for that environment. We have many customers, and we are trying to make humanoid so that they can be used in the field. We are conducting POCs. But as others said, it is not that easy right now. But in the industrial field, I believe commercialization of humanoid would be faster because, as others said, from the perspective of AI or robot, we need to cover all the edge case to achieve commercialization. If we want to apply the humanoid in home, there will be a lot of edge cases and rare cases, and we need to consider how can we handle those edge cases. That is the homework for us. But in the industrial field, there is confined space and confined tasks, and we can perform in a speedy manner. So I believe the commercialization of a robot will be achieved in the industrial field first. In that regards, eventually to apply robot, the key is from the manufacturer's perspective, the ROI when they make investment, how much value they can get. That is the usual logic. From the manufacturer's perspective, they want to replace the human with the robots. And what is the value and the cost? But from our perspective, when the labor cost is greater, it would be easy for us to penetrate the market. In Korea and Japan, the labor cost is very high, and manufacturing environment is quite favorable for us. In this regard, there are other countries like China where labor cost is lower than Korea, but Korea is more favorable for us.
So you talked about some limitations in deploying robots. There are some challenges that we have to overcome, as you described. When we think of humanoid robots, they're as intelligent as human beings, and they can also respond to long-tail issues. But what are some other issues? Humanoid robots require motor technologies or joint techniques that are still technically quite challenging. I saw the Beijing Marathon, which had featured robots. And I saw some human beings lubricating the robot joints. So those are some of the remaining technical challenges. I'd like to now turn to Mr. Chang Han-yong from NCAI, a company that is making the World Foundation model. My name is Chang Han-yong from NCAI. I'd like to first begin with the introduction of our company, NCAI. I think I have 2 minutes, and I'll use the time to introduce myself and my company, and then provide my comment. NCAI is a company that has been working on AI for longer than any companies in Korea. We've been working on AI since 2012, before the development of AlphaGo, and reinforcement training-based AI was developed. You all know that AI developed through generative AI, and now we are discussing physical AI. And in generative AI, game making, programming automation, 3D asset automation, automatic generation are some of the things that we did. And in our company, to follow the global trend, we are also working on physical AI. We are not developing hardware like actuator, rather we are creating World Foundation model and Robo Foundation model. So that's the background. As you described, to talk about the speed of research, of course, a lot of things are happening quite quickly, and we do have challenges that we have to find solutions for. Mr. Song from Holiday Robotics said that there should be some actual applications for humanoid robots and robots. I agree with you in part. Of course, things will happen quite quickly, but there are things that will take more time. What's really interesting is that, as was mentioned by the moderator, the robot marathoner had the assistance from the human beings to cool down or lubricate its joints. For a housemaid robot, you need to have precision actuator, and overheating can cause the malfunction of actuator in a humanoid robot. But if you visit the website of Holiday Robotics, you see a demo video and you see a humanoid robot that changes its main battery by itself. So battery is another issue, one important issue of the humanoid robot. It takes 1 or 2 hours for the human being to clean it and maintain it, but the simple replacement of the battery done by robotics allows humanoid robot working in our homes 24/7. It's a simple task that human beings can perform, and some may say that because the robot has to change its battery, we cannot have 24/7 operating robots, but you see this robot can change the battery itself, so you can work 24/7, and maybe the technology is not developed to a level that will allow the robot to perform complicated tasks that human beings can only perform. However, simple specific tasks like cleaning the house can be done by robots. And service robots or assistant robots can also improve the productivity in industrial settings. So that's why I believe that physical AI can be deployed quite quickly, and it will make significant contribution to improving productivity in many industries. Thank you very much.
같이 이렇게
Thank you. Now, Mr. Chang expressed a positive outlook. And since you are working very hard, I believe it will bring up a positive impact to the robotics industry. Despite this, there are many ordinary people, and for their perspective, they are worried whether they will be replaced by robots or they will collaborate with the robot in the future. I believe Michael Ferry will be the right person to answer this question. So what is your take on?
Lots to talk about here. Rewinding 1 second, you asked a question about what are the fundamental challenges for robotics today. And there's questions about overheating, motors, power. The fundamental thing that we have not solved at scale is dexterity of a robot, the ability for it to grasp a random array of objects. The thing that's so powerful about humanoid robotics is the notion that the robot can go anywhere, that a person can go. It can walk up these stairs, it can go downstairs, it can go across Seoul. There are still challenges with navigation, as Professor Lee was mentioning, but the motor capability of a robot to traverse that entire environment is more or less, in many ways, a solved problem, the physics of it. The thing that has not been solved at scale is the dexterity of the hand, where we have that same level of fungibility between a person and a robot to manipulate a wide variety of objects. You don't know what the robot's picking up, how it's using it, what it needs to do with the object, but the robot is able to figure it out. That is a problem both of motor and actuator design, building up enough of a data set to figure out how to leverage all the different things within the robot's environment to have it do useful and productive work. Persona AI, our background was actually in humanoid robotics development for NASA. We sent the first humanoid robots into space, and a key part of that mission was being able to leverage robots' hands to handle all the tools on the International Space Station. So we're starting to develop that capability so that robots, as they start going into industrial settings, they can do the high-value tasks that people do to add the most value in their workflows, and that's leveraging tools. Persona's first applications are welding robots, so picking up a welding torch and laying down a weld. But as you probably know, or maybe you don't, welding is only one part of a welder's task. They have to do fit up, which means you're taking these blocks and you're making sure the steel plates are nicely aligned together and they're touching before you lay down the weld. After you do a weld, you'll need to pick up an angle grinder and grind down the weld seam to make sure it's nice and smooth. Each one of those tasks is a completely different manipulation set of capabilities that requires highly dexterous hands with enough data to know how to use these tools effectively. And that's a significant challenge. To tie that to your specific question about human fungibility, there's two challenges where robots are very good at doing things that people cannot or should not be doing. One is where the task is too dull, dirty, dangerous, meaning that the job is rote, repetitive, it's hard to staff. It's dirty, meaning it's just unpleasant to do. In my past life, we worked on truck loading robots, which has a 500% turnover in the task at many warehouses because it's just a uncomfortable environment being in a 60, 70 degrees C trailer in the middle of the summer moving boxes back and forth. And then finally, dangerous tasks that are physically hazardous to people where injury rates are high, cuts down their ability to have long-term careers in a particular industry and a particular task. The promise of robotics is not replacing people. The promise of robotics is being able to extend careers and enable people to do more in the work environments that they're currently in. We don't imagine a welding robot at Persona replacing a person. We're imagining one person leveraging 10 robots to do 10 tasks simultaneously. It's enabling them to be multiple locations simultaneously. The edge case problem is going to exist for a long, long time, as Professor Lee was mentioning in the autonomous car world. But having a robot pilot that's nearby that helps the robot solve problems, think through issues, set them up for success, that is a high-tech, high-value, relatively safe task compared to any of the other tasks that would require people to be working close to hot steel that otherwise could potentially endanger their health.
예, 감사합니다. 그 로봇과 인간의 어떤
So human beings and robots can complement each other and they can coexist together. Of course, we need the good technology, but at the same time, we need to look at the moral aspect or ethical aspect of it. Also, we need laws and regulations in our society. Now, let's switch to a different topic. Robot technology is not yet sufficient to be mass deployed because there are some technical challenges. That's what we've been talking about. But if we reach a certain point, the speed of development will be really high. I've been researching technologies for automobiles, but as was mentioned by Professor Lee, in 2023, GM Cruise, the robotaxi, caused many accidents in San Francisco. So the government canceled the license. But next year in 2023, end-to-end autonomous driving technology was developed. It could sense the environment. The technology can control the vehicle using deep learning technology. In 2 years, the technology was mass-produced, and another technology emerged, which was before, when accidents happen, the vehicle could not explain why the system caused the accident, but visual language model is now developed to explain the cause of the accident. So we, of course, heard a presentation on the explainable AI, and in critical missions, the Chinese government now mandates the explainable AI, and now vision action language model is widely used. The speed of change was really fast, it is comparable to the change that happens in the past 50 or 60 years. But as you all know, in the AI field, we have two powerhouses, the US and China. So we are seeing all these physical AI technologies that are being developed and that are changing quite quickly. We'd like to now examine the position and status of Korea, its technological level. We'd like to now turn to Professor Daniel Lee. You've been working in the US, you've been studying in the US and teaching, and how do you see or examine the current status of the Korean AI technology? Where does it stand? You worked at Samsung, so you can talk about your experience in working in Samsung.
I mean, I think the thing that's very attractive about Korea is the talent here, right? The people, you see the passion and the young generation in learning new techniques, being able to study. They get good training in the universities here, and you see that the talent level is very high. The kind of the ambition is there. You know, obviously it's a small country. You know, that's the difficult part of this aspect, is that as we've seen in AI, scale matters a lot. So being able to put more resources into something, put more people in. I mean, this is where I think you see China and US has done very well, because they're able to scale things very quickly and at incredible sizes. So that's the thing that I think hampers Korea a little bit, is that it's hard for them to deploy at scale, to get the feedback, the necessary kind of market to be able to make these kind of more commercial applications. However, I think, you know, with the talent and kind of the position Korea has, you know, my hope is that it could bridge some of these kind of split now that we've seen in the world in terms of science and technology. We now see kind of this huge competition between nations. My personal feeling is that a lot of these problems, you know, dexterous manipulation, these kind of safety issues, are global issues, problems that, you know, not one nation is not going to be able to solve on its own. I would love to be able to see Korea as some sort of broker that could kind of help bridge the gap between competing technologies and competing nations in some sense. And I think that that would be a nice role. My hope would be that Korea would become that kind of nexus point in some sense in AI.
예, 감사합니다. 그럼 이거를 좀 더 깊게 하드웨어 제조.
Thank you. Then let's narrow down to hardware, software, and operation. Now, we have experts from different fields, so I would like to ask their opinion. So let's turn to Mr. Go first. So for the future of K-robotics, what kind of preparation are we making, and how is the progress? Are we catching up with the global trend? Yes. As for the hardware manufacturing, Korea has the strength in manufacturing, and everyone knows that. Conventionally, actually, robot is different from conventional goods, and this is something new. Many people in the manufacturing sector sees that this is a new opportunity, so they are making active investment. And basically, manufacturing is a facility industry, so they use their existing facilities to make the business, and they are currently exploring the opportunities. Indeed, there are many robot-related companies covered by news, but there are other companies such as components companies, and they're making efforts to manufacture those parts and components. And this preparation is not a standalone preparation, rather they are forming alliance to create supply chain. As for Hyundai Motor Company, we are working at the group level to manufacture robots, and we are considering how can we become more efficient. So to sum up, there are many companies making preparation, and we can see some outcomes. And soon you will see the robots in the field, and there will be the validation.
I would like to now turn to Mr. Zhang. So the foundation model is something that we are not catching up. And Cosmos world model can be applied to robot development, as was mentioned by Rebellion CEO about NVIDIA CUDA. How can we make a competitive world foundation model in Korea? What kind of preparations or things do we need to do? In terms, of course, there are a lot of challenges in terms of hardware, but we have challenges in terms of software as well. We are actually are struggling to catch up the US and China, but we still have a lot of challenges. NVIDIA level of technology is really high. I wonder whether there are any Korean companies that can match the technological prowess of companies like NVIDIA. One reason is that I think it's GPU. Software was something that a developer can make using a computer. You only needed human resource. So in the field of game, if you have a good game idea, you could make a good game. But in the era of AI, without GPU, you cannot even make a software program. But fortunately, Jensen Huang often visits Korea. It seems like he has his family members residing in Korea. So we have secured a good amount of GPUs, which is quite favorable to all the researchers and developers. And utilizing the GPU, researchers can carry out research activities. Also, there are a lot of government support provided. So working with the government, we are now working on creating a world foundation model. We started last year. Last year, our research focused on development of LLM, but now, with the support from the government, we are working with other industrial players, and we are working on physical AI as well. And this year, you'll be able to see some progress from the in the area of physical AI. The government has set forth an physical AI development roadmap, and reflecting that, we'd like to continue our efforts so that we can secure comparable technological prowess to the US and China. It is good to hear all those positive remarks from Mr. Zhang. Of course, technology is important. However, actual application is really important. And applying robotics in manufacturing means applying AI technology in the actual industrial settings. So I'd like to now turn to Mr. Song, how Korean companies can be competitive when it comes to manufacturing AI robots.
네, 로봇을 이제 제조업에 이제 좀 사용.
In order to use the robots in the manufacturing sector, we need know-how. Well, your question is quite tough to answer. First of all, let me explain my case. We are taking a different way. We are talking about foundational model, but from our perspective, now we can see the popularity of the foundation model, and many people try to operate the robot on top of the foundational model. But in the manufacturing sector for now, we need to have accuracy and precision up to 99.9%. But for now, we don't have such foundational model with that high accuracy. To compensate that, there must be people, and the same operation should be modeled, and we use imitation model methodology, so human demonstration will be mimicked by robots. So this is the method we are frequently using. When we tried this, we were faced with challenges. Eventually, we need to address the cost of data collection. So when we apply robot to the field, how much data should be collected? Of course, it depends on the tasks, but at least we need to have thousands or tens of thousands of demonstration in many cases. So in our case, we thought that this method of data collection is not sustainable, and whether it is the right way for commercialization, that was my question. So from 2 years ago, instead of using the real data, we wanted to use a simulation data or synthetic data so that the robots can operate by itself. So we focused on the augmented training. In a sense, well, 2 years ago, we were the only company working in this way. However, gradually we can see similar companies in China and the US. They're using simulation data instead of real data, so that we can reduce the number of real data we need. I believe the study is still ongoing. I'm not saying this is our know-how, but if we really want to achieve commercialization of robots, we need to collect real data. Of course, that is one way, but our approach is using simulation data instead of real data. So that is the focus we have.
Thank you very much. So, application itself or deployment itself is quite challenging, and there are many technical hurdles that we have to overcome. Of course, it depends on the definition of robots, but there are many areas where robots are already being used. It's been already 30 or 40 years. If we visited a car factory, we have fixed automation robots. Welding, simple assembly, or the car body painting can be done by robots. These robots do not have intelligence. But we are not talking about those type of robots. We are talking about intelligent, smart robots with dexterity, the robots that can move like human beings. Another way forward could be we have probably should have selective approach to target specific industries. Sophisticated tasks like semiconductor processes or bioengineering may be the potential application of robotics. Mr. Perry is, I understand, working on AI or physical AI deployment in shipbuilding and other manufacturing or industrial settings. So what area or what industries have the potential for AI mass deployment?
There are so many places where robots can be thought about for mass deployment. One of the things that Persona has done is create a humanoid adoption readiness algorithm. This is our internal process to look at each industry and evaluate whether or not using robots, for specifically humanoid robots, is the right technology to go after. In fact, over breakfast, we were just talking about why Persona started pursuing shipbuilding first. And that was a confluence of need. There's an urgent problem in this industry that if we do not solve in the next 5 to 10 years, there's going to be fundamental disruption to the industry. There's product market fit. So is a humanoid robot the best solution to solve this problem? And in shipbuilding, it is, because you have a variable terrain that has these weird geometries that a person has to like snake through and kind of twist their body to reach the full welding surface. We're not going to be disrupted by a wheeled or tracked robot or, Boston Dynamics' wonderful Spot robot. And we're looking at the unit economics. So as Mr. Song mentioned, the labor cost is something that you have to calculate into the ROI for the end customer. If they're paying somebody 10 cents per hour or something like that, the robot needs to provide more value than that. But as I discussed in my keynote yesterday, labor cost is not enough. You have to look at the exponential value that can be compounded beyond what the unit labor cost suggests. So in shipbuilding, that's being able to, we talked about this yesterday, but increase production throughput by 25 to 30% by closing the sense, act, document, verify loop. In truck loading, in my previous life, we were able to increase truck density by 10%. When we deploy robots in power utility companies, we're able to deploy robots into electrified fields that otherwise would be too dangerous for a person to go in and typically requires a shutdown. That shutdown for inspection and maintenance costs $500,000 per hour. So taking a 2-week shutdown and reducing it to a 3-day shutdown because a robot's pre-inspected, done some of the manipulation, tool, maintenance work inside the facility, doing some material staging, that's a transformative value for that customer. So that's where we see the unit economics, the need, the product market fit, operating today. As Mr. Song said, industrial environments, electric power generation, offshore energy production, mining, shipbuilding, these are all places where the product is needed, it's needed now, it's, the form factor is right, and the economics work out. But beyond that, oh man, there's so many environments where we need to think about a new technology to scale up our capability. In fact, last night over dinner, I was speaking next to one of the future speakers about the need for robotics in healthcare. There's just not enough people preparing OR, the materials for OR. There's not enough people handling goods in pharmaceutical facilities, and it turns out that every time you touch a good or move it from one station to another, you're increasing the contamination risk. There's not enough people in elder care. As we are facing an aging population, we need to think about how robotics can help take care of the generation of people that are just not going to be able to take care of themselves. So these are all phenomenal opportunities for robotics to make a difference in the next 5 to 10 years. Industry will be the proving ground where we can get the technology deployed, we're proving out safety, building up the data set to prove reliability, increasing the capability of the robots, and increasing the manufacturing so that the motors, the hands, the joints, the shells, the GPUs all become commodities so that we can start chasing these additional opportunities where the economics and the use case might not make sense today, but it will in the future, and more importantly, it has to in the future.
예, 감사합니다. 역시 그 마이클 페이 대표님께서 말씀하신 내용이 굉장히
Thank you very much. I believe your comment is very insightful because you have field experience. Now the technology is quite limited and the price of the technology is high, but still it can serve as an assistant and it can play a key role in the industry. As you know very well, Korea is a leader in shipbuilding industry, and the hegemony of the shipbuilding industry has moved from Europe to Asia. And actually, when the income goes up, many people do not work in the shipbuilding industry, in particular in the summer season. Welding in the shipyard is very difficult. So I believe it can be one of the application, and as you explained, if there is a contamination possibility, then robot can be applied. Up until now, we covered a lot of topics, and the key is the coexistence of human being with the robots. And for that, robots need to provide convenience, but at the same time, robots should not be the threat to human being. In this morning, we had a lecture from Sue Lee, and Daniel Lee also provided a lecture. And the Chinese government said that the AI used for critical products such as cars should be the explainable AI. And to create explainable AI, as Professor Lee explained, of course, we can have a theoretical approach, but in my opinion, we can also use a visual language model, and we can also use that for the explanation. That is macro approach, because safety is very important. So I would like to turn to Mr. Daniel Lee. And can you talk about safety of the robots?
Of course, it's in these kind of safety critical, life critical situations, we need to be able to guarantee, that the use of robotics, this physical AI, is going to work. You can see this in regulations, right? For instance, in the United States and other countries, anytime you operate an airplane, right, you have to basically verify every piece of software, every piece of hardware that goes into that airplane, and they have to be able to say that it's going to work under 99.9999% of the conditions, and to be able to kind of formally document that. That's kind of the ultimate standard that we have in terms of regulating, the use of any type of automatic systems. And so this will be a high bar to try to satisfy in other tasks. So, we heard that kind of the need to try to find a killer app where maybe the safety is not as big of an issue for humans, but that there's a kind of a good cost-benefit analysis in terms of the use of robots. And I agree that that's where industry and companies should focus on. But still, if we really want kind of the ultimate general purpose intelligence robot, we're still, have to think about research and development to be able to get there. So, let me throw out a task that I think is a uniquely Korean task that it would be great to see a robot be able to do. So as you know, in Korea, we have a good custom when you go to eat, you drink soju with each other, and you need to pour soju for each other, when the other person has an empty glass and they want to drink more. And this kind of social interaction type of robotics, right, this interaction between robots and humans, what would it take to achieve that kind of performance? So first of all, we need AI that can kind of understand what the human's thinking, right? Whether this person really wants another drink, or are they receptive to emotion, right? These are the things that still our AI systems are not capable of, as well as what people with EQ have. And then the actual task of being able to pick up, a soju bottle, being able to pour that into a glass and to be able to hand it to a human being. I mean, these are very difficult problems that, like the manual dexterity, but also to just understanding what could happen, right? As you know, in these situations, things can be very wet, can be very cold. Depending upon that kind of physical situation, we as humans are changing our grip. We sometimes hold the bottle in different ways to compensate for the physical environment. These are still things that physical AI still has lots of problems with. This is why you hear a lot of talk about better world models for physical AI. This is exactly what it means, right? How can the physical AI understand the friction coefficients of this bottle? What could happen when it slips? How to make sure when it does slip, it doesn't, spill on the other person, but spills on the floor, right? These are all the types of things that we as humans compute inside our heads. And being able to have an AI that can do that, I think, would be incredible, but we're still a long ways away from that. So this is the types of scenarios that I think that we would love to be able to see, but still will take time to get there.
예, 그 기초 강연.
During the keynote presentation, you talked about the white box AI. That's the opposite direction from deep learning AI. The black box model is trained. Of course, we may use some heuristics, but making it white box will lead to highly complicated mathematical problem. And that can also be performed by AI to understand why certain parameters are chosen. And then we can secure better safety compared to language models, right? Is that what you are talking about?
Interesting to compare humans, how we learn to do these tasks, right? We don't need a million examples of a particular situation to be able to do it. Well, like in the medical field, right? If you're a medical resident, the dogma there is, see it once, try it once, and then you're doing it, right? That's kind of, basically one shot, two shot type of learning. And this is still something AI cannot do, right? We still need lots and lots of data. We're training continuously. Can we make better models that we understand how they're built, how they're incorporating, the various physical parameters of the situation, put that into the model so that it could actually learn as fast as a human can. This is something that we still haven't achieved yet. And that's why it'd be nice to see models that could do that.
네, 감사합니다.
Yes, thank you very much. So we've been talking about various aspects of physical AI, mainly robotics. Now it's time to take questions from the floor. Now we will open the floor to hear from the audience. If you have any questions or comments, please raise your hand. Physical AI, robotics are the topic of our discussion, and we have invited the experts. So if you have any questions, I'm sure that you can get the answer today. So if you have a question or if you have a comment, please raise your hand, and I'm sure that somebody will deliver a mic to you. I saw a hand raised. And also, please identify yourself. Let us know what you do. That will be really useful. So at the back of this hall, I saw a hand raised.
안녕하세요.
Hello, I'm from Konkuk University. My name is Kim Soo-jung. Thank you very much for putting together this important gathering. I have a question. When it comes to physical AI and humanoid robots, we heard a lot about them, but I'm also interested in collaboration between robots. What is the progress now? what is possible. Let's say for welding robot, one robot may be holding a steel plate and the other robot may do the welding work. If the first robot does not hold the steel plate correctly, maybe the welding robot can give instructions to the first robot to change the position or move a little bit. But from the first robot's point of view, maybe he does not understand the correct position of the steel plates, and then maybe can communicate back to the welding robot that this is okay, you can still weld. We also heard about the robot that ran the marathon, also heard about the cooling that was required during the race. Maybe different joints have different heating patterns. Maybe there will be another robot that can be used to identify the different heat signatures of different joints and spray the cold water, not cold water, but does the cooling for the areas that will require cooling. And if the cooling is not sufficient, the robots can communicate each other to ensure that the cooling is properly done. So I think it was a really different story, a different perspective. Probably you have a lot of experience, Mr. Perry, so you can answer this question.
You're asking all the fun questions, so thank you for that. In the field of robotics, we're always looking for interesting novel problems and inter-robot communication, whether that's a humanoid talking to another humanoid and collaborating on a task, or a humanoid talking to a wheeled or tracked robot or a spot robot. That interoperability of communication to tackle a complex task is really at the forefront of a lot of really interesting research, and there's some cool things that are happening in that space. Backing up a second, though, one of the fundamental challenges that we are facing, at least on the deployment side, is trying to make sure that the unit economics make sense and that the uptime utilization of the robots is as high as possible. So to that end, there has to be some level of fungibility between what you're expecting in the cost structure for a particular task from a person to a robot. And in many cases, for example, in welding, there are tools that an individual welder uses to solve the problem of plate alignment. That means it's incredible what these guys do. Like from a physics and whole body control problem, it's like mind-boggling. But these welders will use a crowbar and kind of put their foot on the crowbar to push it up so that it's aligned with the plate. And then they bend over and weld. Holy cow, that's a tough robotics problem. But we have to solve it at that level of performance for an individual robot, because if we're using 1, 2, 3, 4 robots to all get one task done, the cost structure has to still make sense. So we're trying to optimize as much as possible to a single robot doing a single task. There's some things that are just not possible with the human form factor to do as a single person. So one of the tasks that Persona is really interested in is rigging. Rigging is where you have a dangling end of a crane and you have to hook it around large objects so that it can be moved in construction or energy or transportation logistics. When you're leveraging a crane that way, you have to take one end, feed it through the object, and have somebody on the other side receive it and then hook it around on the other side. To that end, because it's a two-person task, because it sufficiently requires a robot that's working with another robot, that's the type of opportunity that we look at to say, this is the right cost structure, this is the right application where multiple robots can be useful. This is not a fully solved problem. There's a lot of complication, vision, interoperability, communication, the dexterity piece of the puzzle. They will need to come together. but there's a plausible path to get this done within the next 2 to 3 years.
감사합니다. 멋진 질문에 멋진 답변이었습니다. 예, 저 뒤에 아까 먼저 손 드신 여성분.
Thank you. That was excellent question and answer. And we have another person asking a question.
In English. First of all, participating in this AI forum is incredibly meaningful for me and deeply grateful for this opportunity. I'm currently preparing for a professional licensing exam and consider myself a passionate power user of AI. I have so many questions swirling around in my head, but let me dive right into the first urgent one. While today's discussion centered around the robotics and physical AI, the AI practical experience in my everyday life is limited to tools like Gemini or ChatGPT. Therefore, I'd like to shift the focus a bit, ask a broader, more big picture question. As Professor Daniel Lee explained, AI operates like human neurons formed in countless geometric shapes, allowing AI-driven robots to process a vast amount of data and generate incredible creations. As a power user, I found this absolutely marvelous. However, it also leaves me constantly figuring out how to maximize AI's potential for my own work and learning, and how to estimate its possibility to enrich every part of my daily life. I believe that robots and advanced AI should ultimately be used practically in every personal chunk of life. This question might sound a bit abstract or too broad, but could you share any practical recommendations on how we can best integrate AI into our daily routines, not just for robotics, but for general AI utilization as a whole? Thank you.
예, 감사합니다. 질문이 3개 있는 것 같은.
I think there are 3 questions. The first one is a program-related one, so I will answer the last one, and the second question will be answered by Professor Daniel Lee. Please go ahead.
I think that's how most of us are using AI a lot of times in our life, right? We ask ChatGPT or Gemini to look at some text or to help us, ask a question, general question, and try to, basically read using language models. So, these, and I'd like to hear from some of the other panels who are using foundation models in robotics. That's kind of how we, as you say, most of us as users are using these foundation models. You have to realize that these were trained basically on text from the internet, and they're just basically doing next word prediction. So the way a language model thinks about the world is in terms of words, a textual description of the world. Now, what makes it hard is that to hook that up to a robot, which, think about trying to describe how to do welding in terms of words, right? It's very difficult, right? Like what's the flame size should be, where the plate should be, as we heard. This is very difficult to write in terms of language. It's much better to try to think about how to describe that in other mathematical ways. This is what the world model that I mentioned before is trying to do, is having a kind of a better representation of what the outside world is. And this is hopefully will be available in future AI systems. But I definitely think that foundation models, we see the power of these things in terms of being able to plan your vacation, being able to describe, questions that you have or give answers to questions you have. So that's definitely how people are trying to do robotics a little bit today, but I think it's limited because of the kind of constraints on language in describing the physical world. So it'd be great to hear about foundation models and other people too.
예, 감사합니다. 혹시 정한용 실장님 추가하실?
Mr. Jung, is there any additional comment you would like to add? You spoke in English. So I didn't expect that I will answer this question, but let me talk another thing. At Meta, Zuckerberg is making AI. I'm not sure whether you know about this. AI can be used for meeting minutes, but eventually we need to enter all the knowledge we have into AI. Then we can fully utilize AI. Otherwise, there are limited questions we can ask, and it has limited background information, so it is not that easy to have the right answer from AI. So without this process, ChatGPT will not give the correct answer. So we need to try and try. If you want to maximize the utilization of AI, I think we first need to create the clone of me. In physical AI, maybe this is dangerous, but if you want to create the physical AI that can replace you, then I believe in your field, you will see what is the way to maximize the use of AI. Thank you very much.
제가 먼저
I'd like to also provide my answer to the question. As a moderator of the session, I'd like to first thank you for raising the question. I wondered or was worried that there may be no questions from the floor, but I'm happy to see that there are many questions being raised, and it is a really good one that you asked. When we talk about robotics, and of course we want to make sure that human beings can coexist alongside the robots. The robots should not threaten the existence of human beings, rather it should benefit the human society. And as a moderator, I worried that there would be a lot of negative comments about the potential harm that robots can pose. But however, it was really good to hear good remarks, positive remarks, and also good to have these provocative questions. And the reason that we are discussing this topic in the first session of SEOUL Forum 2026, as you know, we are living in the era of AI and AI robotics. We went through AI winter and saw the reemergence of deep learning and AI. And back then, we talked about AI that could distinguish dogs and cats images. But during the pandemic AI, we saw the emergence of generative AI. And now, we have AI that can reason and think. Starting from last year, we started to see another new trend. And now people talk about physical AI. Jensen Huang talks about it. We want, and we are developing, not AI as a digital form, but we want to have a physical AI that can really act. And I understand that the forum organizer has chosen the topic reflecting such technological trend. I understand that you are not studying AI, but you said that you're using AI a lot in your everyday life. So it was really good to hear from you. I'd like to see or check whether there are any questions from the floor.
AI, because I felt when I'm using AI, it seems like the Gemini or ChatGPT has a ethics standard. So, but in this session, we worried a little about, no, not little, we were worried about the ethics of AI. So, but if we can put some good ethics standard in ChatGPT or Gemini, then can we a little bit can we be little bit makes better the anxious about addict problem of users, or giving the tools. I mean, we worried about the addicts problem of ChatGPT or Gemini. Sometimes they give us very stupid the answers or very dangerous answers. But sometimes I feel there is some ethics standard when I got some answers from Gemini or ChatGPT. So what's this happening? And then can you make a little better solution about this problem?
마이크 페리 대표님이 이렇게 마이크를 잡으신 것 같아서 답변 부탁드리겠습니다.
Mr. Perry, do you want to answer the question?
Sure. This is a question more generally about AI and digital AI. One of the challenges that has been happening is that the industry has more or less been defining its own standard. The way that you circumvent the challenge of, the probabilistic answer that the model is coming up with turns out to be wrong or misinformed or hallucinatory. The way that the industry gets around that right now is by saying, hey, please check these answers. There's a little dialog box underneath the question, the prompt box that says, hey, please make sure that you check these answers. ChatGPT can make mistakes. That is important. But there's a question of whether or not additional regulatory information or standards need to be in place to ensure ethics and misuse is avoided using these technologies. These are some of the challenges that many countries are trying to take up now, but in many ways it's late. I wouldn't say too late, but it is, as the English saying goes, trying to get the horse back in the barn. The horse is out of the gate, you gotta figure out how to corral it. This panel is really focused on physical AI. And to that end, there already are a large number of robotics standards that are applied to how robots are used, the safety standards, the power interfaces, all these different components of a robot already set by a wide variety of standards, whether it's from RIA, ASTM, NIST, several others, that can start helping us benchmark where the robots are, where they should be, and where they should be applied. I'm not saying that these models are perfect. In many ways, you could argue that they're outdated. They're referencing former models of robots that are highly programmed or operating in a completely unique environment. They're set off by cages so that there's no risk of coming close to a person. So those models need to be updated more to keep pace with the evolution of the technology, but we're in a slightly different position rather than trying to take this incredible technology that's suddenly let loose on the world and trying to dial it back. Instead, we're taking these other standards and inching it forwards. I would say that those apply mostly towards safety rather than ethics. Ethics is a much broader question, but the great thing about safety is that in many ways, it's aligned with ethics, and in many ways, it's a more objective standard. So we can measure whether or not a robot is safe or not. It's very hard to imagine, create a measure that whether or not a robot's ethical or not.
Okay.
I can add a little bit to that. So I think you should realize, how these AI systems are built, Gemini, ChatGPT, is that they train a model, but then they do a lot of what's called post-training work, where they try to filter the outputs of these generative AI models to better align with human taste. Right, so this is called human reinforcement learning in the loop there, to try to make it think so that the output is something that the human users would actually like. And so this leads to something called confirmation bias, right? Because it basically gets trained to kind of make you feel good, even though maybe it's not the right thing to do. So that's why you hear these stories about generative AI, helping, trying to encourage people to commit suicide because they think they'll make you happy, because it just doesn't understand the situation. I think a similar thing with physical AI is that, there is no kind of filtering right now in terms of what the output of physical AI does. We also need to think about, what aligns with good standards and regulations and put guardrails on that. As you know, maybe, physical AI, one big use case would be kind of militaristic uses, right? But we don't have any guardrails about that. So these are all the kinds of issues that could come up in terms of thinking about how we can kind of properly kind of put some sort of scope and sort of filtering on top of what companies are building right now.
네, 감사합니다. 시간 관계상 마지막 질문 그럼 두 분 질문하도록 하겠습니다. 저 먼저 손 들으신 저 가운데에 계신 여자분하고 저쪽에 계신 여자분한테 마이크로폰 좀.
안녕하세요.
Good morning. I recently graduated specializing in industrial engineering and computer science. And let me give you the question. Professor Daniel talked about medical dogma, and without training thousands of cases, we need to have the robot. That is the ultimate goal. So do you think this is technological issue? And do you think there is a huge gap between human being and robot? Or is this a regulatory issue? So we are more stringent to the era of robots. And my second question, recently, I started my social life, and I realized that the society is changing really fast. As for the computer science field, it is totally different when I entered the university and graduated the university. And if there is any advice for the people starting a new career, please, I would like to ask for the advice.
The second question first. As you mentioned, this field is moving very quickly. So I know for the young generation, it's a time of high uncertainty about, career choice, what will actually be useful in the future. I can tell you from the actual academic professor side, it's also extremely kind of discombobulating where, what we're teaching today, is it really the right thing to do? So I think, we need to all think carefully about, what will happen in the future and how to prepare properly students and the young generation so that they will, find something valuable to contribute and to find purpose, right? This is, I think, really a key question. And then I think your first question was about, can you repeat the kind of question the first time? The first question was, do you remember?
I forgot to.
Okay.
첫 번째 퀘스천이 뭐였죠?
Yeah.
What was your first question? Please use the microphone for the interpretation.
How to better interpret these models? To use that? Is that the? I'm sorry.
It is more about asking if there's a huge gap between human and robots' mechanical, like physical ability, or if it's a problem for us being too strict on robots' like failure rates and accuracy.
Yeah. So I think it's a great question. It's basically a big philosophical debate right now in terms of AI, right? Where it stands compared to humans. Right? Some people say it's approaching super intelligence, that they're going to be much better than humans and everything. But then as we heard the Moravec kind of a paradox where they could be better in certain things, but they can be really stupid in other tasks. So then, how do you compare? So, and then, how do you regulate, what they're used for? I mean, these are all kind of deep societal questions that I think none of us really have an answer for. I think this is going to take more study and experience to be able to determine exactly the boundaries of everything. So no, that's definitely something that is still, I think, open for big debate.
예, 마지막 질문으로.
Let us hear the final question. Please use the mic. I'm from Gyeonggi University. I'm studying international studies. I have two questions. First, in the industrial settings, we want to minimize industrial accidents. Of course, we have human supervisors, but who bears the responsibility if any accidents happen in industrial settings? And maybe there are some developments that are being made to assist human beings or to reduce accidents in industrial settings. And also I heard somebody saying that Korean can be a broker between two powerful countries to lead technological development.
You know, it's a great question. How do we kind of guarantee safety in these kinds of systems? I think actually maybe some of our industrial panelists can try to answer how they try to guarantee whatever they're building will actually be safe for humans. I think that's great, that's fabulous. But I do, on the second part though, I can answer in terms of, I would love to see Korea really become, you know, I think Korea is known to be very open, inviting culture. I would love to be able to see that kind of transition into the scientific and technical domain, especially in physical AI, where we see so many kind of news and stories about this kind of competition and being secrecy. And for me, you know, as I said, these problems such as guaranteeing safety is such a difficult problem that, you know, we shouldn't be restricted and partitioned in terms of being able to do research on that.
예.
Thank you very much for your question. It is time to wrap up our discussion today. When we began our discussion, I asked all the panel discussants to make an opening remark. But as a moderator, managing the time is really important. We want to also have lunch now. I'd like to thank you for your participation today. We were able to hear from experts, and it was really valuable insights that you shared with the audience. Also, the questions were excellent today. And because of your excellent questions, we were able to have really in-depth discussions. Once again, thank you very much for your participation. Let us work closely together so that we can develop physical AI that can benefit the entire human society. With that, we will conclude the panel discussion session. Thank you very much. That was a really good discussion that we had. Professor Hong, thank you very much for moderating the session. Also, please give a big round of applause for all the panel discussants. That was the panel discussion that we just had on the topic of redesigning the industry. We examined different applications of physical AI and robots, and also we were able to understand different developments pursued by different companies. It was a really meaningful discussion that we had. Thank you all very much for your participation today. Now we are going to have lunch, and the lunch will be served to you in your seat. A lunch box will be provided. I hope you enjoy your lunch, and the afternoon session will begin at 1 o'clock. Please enjoy your lunch.